it later if they wish. All right. Now, I'll open it up to to any questions somebody might have right up front. Is there anybody who would have any questions about our test that's coming up? Any specific questions? Okay. And also people could turn their videos on too, so I could see you. This review session is really for you. I want to make sure that you're paying attention. All right. Okay. Just no specific questions. So let me share the screen. And we'll go right into the textbook. Let's see, so hold on one second. All right. All right. So just give me a thumbs up if you see the screen here. Good. All right. So we'll look at chapter 7 first. We'll look through some of the exercises in here. I want to focus today mostly on the quantitative type questions. There's obviously going to be some concept questions on the test, but the best way to prepare for them is to read the book, read the chapters. And the chapters that we're covering for this test are chapters 7, 8, 9, 10, 11, and 12. All right, 7 through 12. All right. So I think the best use of time today would be on the quantitative the questions. All right. Now, chapter 7, remember, has to do with charts and numbers, right? Charts and numbers. And so one of the things I want you to have with you today and practice as we go along is a calculator. All right. So we need our calculator to be ready to go. And here's a data set that we see right away, question number 1. Okay. So we can use this data set for now to do some of the quantitative questions. So let me just go to the calculator for a second and show you how to enter data into the calculator. All right. So here's our calculator here. I'm assuming that all of you are the ones who have calculators are using this one, because I've asked around and it seems like all of you are using this one, the TI-30XS. Now to enter data, you're going to hit the data button, which is really the one in the middle here, upper middle, third column. All right. So if you hit the data button, you end up with these lists. So we have L1, and if you scroll over with your right arrow, you'll see our L2 and L3. There's 3 different lists. So sometimes you'll need more than one list, especially in chapter 10. All right, but now we're just dealing with chapter 7. And to enter a number, you just basically hit just type in a number. Let's say just type in 98 and hit enter. Right. So it enters it in the first column, list 1 and row 1, and then it takes you right to row 2, and then you can enter your next number. All right. So what I want you to do, that's hopefully no explanation more is needed for that. So what I want to do next is to go back to the data set and show you the data set. All right. And while you're entering the data, I'm going to enter it also. All right. Just give me a second here. Many darn things on my screen. All right. So this is the end of chapter 7 exercises. All right. And there's your data set. So go ahead and enter it into your calculator. And I'm going to do the same thing in my calculator. So this is question number 1. It'll take me a couple minutes to get set up here on my calculator. So go ahead and take your time, make sure the numbers are correct. And enter them all in L1. All these numbers that are in this data set. All right, so there should be 31 numbers. And maybe anybody still working on it? Just yell out if you're still entering the numbers. Everybody's good? I'm going to unshare the screen to the calculator. Okay. All right. Now I don't care about all these. What you see on the right here. This is not something obviously you're going to see. This is just a repeat of what I entered, so I'm just going to clear it. It's not too confusing to you. All right. All right. Anyway, those are the 31 numbers. Notice that if you scroll down to the very next one, which is blank, it's 32. So it's 31 numbers. And that now what we're going to do is we're going to look at some statistics that this data set represents. So we're going to hit the second button, and right above the data button says stat. So that's what we want. Second data, which is the stat button. And then it's giving you these 2 choices. Now, if you just have one variable, in this case, one set of numbers, then you're going to use one var statistics with one var stats, which means one variable statistics. So just hit enter with that. Now, what it's asking for here is which list is the data in. Now, if you have more than one list of data, then you have to tell the calculator which one you're looking at. Now, it's automatically going to L1 because that's what is highlighted. Now, if the data was in L2, you'd have to scroll over with your right arrow button and hit enter, so L2 would be highlighted. But in this case, we just have the data in L1. So we just scroll down. So hit your right lower arrow button here. Scroll down. Frequency, leave it as 1. That's fine. And then go to calc. Calc will be highlighted, and then hit enter. All right. So here is summary statistics for this data set that we just entered. Now, tell me, now sometimes the professor makes mistakes. I want to make sure that I didn't make any mistakes when I entered the data. But this should be what you're seeing, right? The first 3 numbers. N is representing the number of numbers in the data set. There's 31 numbers. The second number, has an X with a bar above it, that is called the sample mean. The sample mean. Now, in this course, at least when we dealing with data sets, we're dealing with samples. All right, so that's the sample mean. And in other words, if we added all 31 numbers up and divided by 31, we would get this number, 76.29. Give me a thumbs up if that's what you see on your calculator. Are you seeing that on your calculator? How many people are actually using the calculator? You need this calculator for your test. How many people have this? The thumbs up. Anybody? Good. Adam, I see Adam there with thumbs up. Good. Thank you.
Yeah, when I put data, when I press data on my calculator, for some reason it says error. It says stat error right away. I'm not sure why.
You hit your data button and it shows an error.
Yeah, it says error right away.
Well, then you need to reset your calculator. Just hit the second button and all the way down where the 0 is. It says reset above it.
Yes.
Hit that second 0, and then follow the directions. Just reset the calculator and start all over.
Okay.
Right? See if that clears out that problem. If it doesn't, now these calculators, I believe, are they have batteries. I guess they have batteries, don't they? I guess they do. Unless they're solar, maybe they're solar. They have solar cells in them. That could be. So if they don't have batteries, it shouldn't be any problem. So if you're having one that malfunctions like that, you just have to reset. All right, who was that person who just spoke?
Kevin.
Kevin. All right, you reset, right? Now, when you hit the data button, now turn it back on and hit the data button, you still getting an error?
Yes, it's just a stat error.
Okay.
Yeah, it's weird, but that's fine. I'll figure it out.
Malfunctioning calculator, that can't be right.
Yeah, it's right
An
away.
error on data, because data is just the screen that enters the data. There shouldn't be any errors there.
Yeah, it immediately says that error.
Why don't you do seconds data and see what happens? You still get an error message there?
It says 1 var and 2 var.
What? Oh, the one. All right, so it's giving you that correct.
Yeah.
All right. Why don't you go into mode? Hit the mode button.
Okay.
All right. And what's highlighted there? It should be DEG, right? And then, and how about the one below that? It just says norm. Is that highlighted?
Yeah, I don't see anything. I don't even see the mode button here because I have a different calculator than this one, but it's fine.
Oh, you have a different calculator.
Yeah. I have
well, you should told me that. Maybe there's some calculators. Let me mention this to you. Some calculators require you to get into stat mode. All right, this does not. This is why I picked this one, so you don't have to deal with issues like that. But sometimes there's certain mode you have to be in to do statistics with certain calculators. So, all right. So yeah, it's a different calculator. I'm giving you the steps just for this calculator.
All right, no
do you have what is the name of the calculator?
It's the TI 30X2S.
30X2S. All right. So you have the older version. And I think you have to get into stat mode with that. Can everybody just give me a second, because I have that in my briefcase. Let me get that calculator and I'll just quickly tell you what to do. Hold on.
Thank you.
All right. Now, in your calculator, the data key is 3 rows down. Is that correct?
The
3
yeah,
rows down from the top.
yes, yes,
All right, because this is 2 rows down, right? Okay. Now, right next to the right of it, it says stat variable, right? It says that too?
yes.
All right. So you're out of the stat mode. So to get back into the stat mode, you hit second stat and choose one variable and hit enter. And then hit your data key.
Okay. Second stat.
Hit enter and then hit your data key. And it doesn't have the lists. You basically have to enter the numbers one at a time.
Okay.
All right. So
Thank
I
you.
recommend the newer version because it's easier.
Yeah, definitely.
This was the older version of the one that we're looking at.
All right. Thank you, Professor. I appreciate it.
Okay. All right. Anybody else have that calculator? Can yell out. Everybody else has the newer one. Okay. All right. So let me go back. Now, what we did before was we did second stat. See, we're doing it in reverse here. With this newer version, you have to put the data in first and then choose what you want, and it gives you the answers, right? So I'm choosing one variable statistics, and then I'm saying that it's an L1, right? L1. That older calculator doesn't have L1. And I hit calc. Okay. And this is what we were looking at before. Number of numbers, 31. The mean, that X with a bar above it, is 76.29. That's the average. Now, the next number that's below that is called the standard deviation, the S, with the X next to it. If you remember, that is the average spread of the data, right? It's the average spread of the data. On average, how far apart are all the data numbers? In this case, about 13.8 units apart. We have a mean of 76.29 and a standard deviation of 13.8. Now, the variance, which might be mentioned in the book, is the square of the standard deviation. So that number, that third number there, 13.847, if you square that number, you get what's called the variance. But typically, the standard deviation is shown right here with the calculator. Now, the question is, what else does this calculator show? Okay. So now notice next to the 3, there's a down arrow button, which says there's more numbers below. Now this next number 4, that there's a slightly different formula for the standard deviation when we're talking about a population. But in most cases, the data set we're looking at is a sample. So if I ask for the standard deviation, use option 3. All right. Okay. You don't usually use the sum of all the numbers. This number 6, we don't usually use that. That's telling us to square all the numbers and add them up. Here's the numbers that you do need to know. This is the smallest number in the data set, 36. Now, the next number says Q1 equals 65. That's called the lower quartile. 25% of the numbers in the data set are smaller than that. Okay? That's what we mean by the lower quartile, Q1. 25% of the numbers are less than that. Now, that 5-number summary that we talked about before, with the box, with the rectangle, where you put 5 numbers in the box. This is where you get where you would get the numbers if you entered the data set. All right. So Q1 is 65. The median, that means 50% of the numbers is less than this number, 78. That's 78. That's the median. Q3 is the upper quartile. That means 75% of the data is less than that. That's 85. And then the largest number in the data set is 99. So if I ever need to ask you for any of these 5 numbers, besides the mean, all right, and the standard deviation, this is where you would find it, right here. All right. If you were entering the numbers into a data set, that's the key, if you were doing that. Now, if I gave you these numbers, of course, then you would use them, obviously. But this is how you take a data set and find these various numbers. And these are the ones that you would need to know, possibly in for this test, possibly. I'm not saying you do need to know all of them. You need to know the mean. Let's go back. And number 2 there, that's the mean. Number 3, the standard deviation. Number 7, the minimum. Number 8, the lower quartile. Number 9, the median. This next one, which is A, I guess, is the upper quartile, Q3, and the maximum, this largest number in the data set. Now, there are certain calculations that you can do with these numbers. For example, if you take the maximum number in this data set, which is 99, and subtract the smallest number, which is 36, right? 99 minus 36 is 63. That's called the range. It tells you the distance between the largest and smallest number in the data set. Another number that's commonly asked sometimes is called the interquartile range, or IQR. And that's Q3, the upper quartile, minus Q1, the lower quartile. That's 85 minus 65, which is 20. Another thing that we can say about these numbers, this 5-number summary, is that between the smallest number or minimum number, 36, and Q1, 65, that's 25% of the numbers are in between those two numbers. That's all right. Then between the median and the lower quartile, that's another 25% of the numbers. That's between 65 and 78. Between Q3, the upper quartile, and the median is another 25%. That's between 78 and 85. And finally, between the largest number and Q3 is the final 25%. So the 5-number summary splits your data set into 4 pieces. That's 4 quartiles. All right, 25%, 25%, 25%, and 25%. So if I said something like, what's the percentage of numbers that's between 36 and 85, you would say 75%. All right, because from the minimum, 36, to Q1 is 25%. From 65 to 78 is another 25%. And from 78 to 85 is another 25%, and that's 75%. So I can ask questions like that. All right. Now, one of the ways to display a 5-number summary is with what's called a box plot. All right. Let's stop sharing this for a second. I'll show you what a box plot looks like in the book. You need to focus on that also. There's a bunch of people just coming in now. It's weird. It's 11:30. All right. So I don't know why everybody's coming in so late. All right. So let's now go to our book. All right. I don't know what's going on here. The same person keeps having trouble coming in. All right. All right, so let's look at a box plot. Let's just take a quick look at one. And also, let's take a look at what the box plot helps us do. Here we go. All right, so let's see what one looks like. Okay, number one, if you see a rectangle that has these 5 numbers in them, in this case 7, 6, 8, 3, 16, that's the 5-number summary. The number that's on the top is the median. That's 7 in this case. 6 and 8. 6 is the lower quartile. 8 is the upper quartile. So 6 is Q1, 8 is Q3, and 3 and 16, 3 is the smallest number, 16 is the maximum. Okay. Here's a box plot that represents all those numbers, this data set here. All right. And a box plot is just a picture of the 5-number summary. Now, this box plot is horizontal, but you can have them go vertically also. All right. So just know if you see this vertical, then the lower part of the box plot is the smaller numbers, and the higher is the bigger numbers. In this case, because it's displayed horizontally, the lower numbers to the left, up bigger numbers to the right. All right. And we can see the smallest number. Now, what does the box represent? That is the middle 50%. The left part of the box is the Q1, lower quartile. That's 6. The right of the box is the upper quartile. That's 8. The line inside the box is the median. In this case, it's 7. It doesn't have to be exactly in between 6 and 8. It could be more to the 6 or more to the 8, but in this case, it's 7. Now, this horizontal line coming out of the box plot, sometimes they call them whiskers, box and whisker plot, sometimes this is called, represent numbers. The one on the left here represents numbers that are smaller than the Q1, the lower quartile. In other words, this is the lower quartile, going from the smallest number all the way up to 6, from 3 to 6. On the right, notice that the horizontal line ends just before 11, and then we have these 2 asterisks that are there, or stars. And these represent outliers. Now, I'll show you in a minute how to calculate an outlier, because you do need to do that on your test. It's not that hard to do, but you need to write it down, and it's in your book. It shows you how to do it, but we'll go over it. Now, 12 is a outlier and 16 is an outlier. So from Q3, which is the upper quartile at 8, all the way up to the maximum number of 16 is the upper 25% of your data. So the horizontal line that stops just before 11, that's a number in the data set that is not an outlier. That's the largest number in the data set that is not an outlier. And then there's 2 numbers that are 12 and 16. Now the question is, how do you determine whether 12 and 16 in this case is an outlier? Or maybe there could have been an outlier small, on the left here. Maybe it could have been a star to the left, but there isn't. But how do you determine an outlier? And an outlier means a number that's either unusually big or unusually small. So what you need to do is you need to calculate the interquartile range. Again, that's Q3 minus Q1, upper quartile minus lower quartile. In this case, it's 8 minus 6, which is 2. All right. And let me see if they actually show it in the book. They should show it in the book. So let's just take a quick look. Yeah, here it is. So this shows you how to create a box plot. You do not need to be able to create a box plot in this course, but you should follow these steps, because one of the steps is to determine if a particular point in your data set or number in your data set is an outlier. So you calculate the interquartile range, that's number 4. And that's the width of the box. That's how long the box is. And then number 5 is to multiply the IQR by 1.5. I think if you remember, we did this in class. So if the interquartile range is 2, 8 minus 6, you multiply that by 1.5, you get 3. Now here's the calculation. You take your 3 from step 5 and you add it, number 1, to your upper quartile, which is 8. And you get 11. Any number in the data set that is bigger than 11 is an outlier. And then you also you take your 3, 1.5 times this interquartile range, and you subtract it from the lower quartile. In this case, 6 minus 3 is 3. Any number in the data set that's smaller than 3 is also an outlier. Well, it just happens that two numbers in the data set are bigger than 11. And what were they? 12 and 16, right? If we go back to the box plot, 12 is bigger than 11, 16 is bigger than 11. So both of those are outliers, and typically people put little stars next to those to indicate to a person looking at the chart that they're unusually large numbers in the data set. Now, are there any small outliers? Well, remember, we took 6 in this case and subtracted 1.5 IQR, which was 3, and we got 3. Well, we know that the smallest number in the data set is 3, but the rule is that any numbers that are smaller than the lower quartile minus 1.5 IQR, any numbers that are smaller than that number is an outlier. Well, 3 is equal to that number, so it's not an outlier. Okay, and of course, since 3 is the smallest number in the data set, obviously there can't be any other outliers at all on the lower end. All right, so down here where the small numbers are, none of these numbers are outliers, because then the smallest number is 3, and to be an outlier, small outlier, you have to be smaller than 3, and there's no numbers like that. All right, so in the test, you will be asked, you may be asked, I'm not saying that it'll tell you step by step how to do this, but it'll ask whether some number is an outlier. All right, and it might be a true false type of thing. So just know that you have to calculate the interquartile range, and you'll be given a box like this probably. All right, so you'll know the 5 numbers, and you'll know that the 2 middle numbers need to be subtracted. All right, in this case 8 minus 6, and then you need to multiply by 1.5, and then you add that to Q3 to get the number that has to be bigger than that number to become a big outlier, and then you subtract that number from Q1, and then you know you need a number in the data set smaller than that to be a small outlier. All right, so that's basically what I wanted to show you with outliers. Any questions about that? Again, I showed it in class, right? So hopefully you were there, but if you were not there during that class, well, what does it mean? It means you need to read this chapter. This chapter is a very important chapter for this test because it gives you the basics of how to do statistics. These are basic ideas, all right? It's not supposed to be the hardest part of the course. But anyway, here's the 5-number summary displayed in a box. In this course, we use this book, and this book is the only book I know of that puts the 5-number summaries inside a box like this, but it certainly seems to be visually appealing, and you know where all the numbers are, and you should be able to know where these numbers are, because why? You have the textbook opened up, right? And if you see a question like this, you go to chapter 7, and you go to this page here, and it shows you which of those 5 numbers are where in that inside the box. All right. So that is the important thing to know. All right. For this test is now histograms are another way of displaying quantitative data. Now, number 7, chapter 7 is all about quantitative data, right? And so a histogram displays quantitative data like this. Okay. And when you look at a histogram, number 1, it's usually displayed with the x-axis where the quantitative number is, and then the y-axis is typically a count or frequency. Now, it is possible that the y-axis is not just a count, but it is a percentage. All right. So the way to read a histogram is, notice that, let's look at this one right here where it says 70,000 just below it, this rectangle here. Notice that its height is 8. Now, in this particular case, because 70,000 is in the middle of this rectangle, all right, then a little bit below 70,000 and a little bit above 70,000 is probably the range of the income for this rectangle. Now, sometimes the rectangle represents just one number. Okay, now in the test, I'm making it easy for you. The rectangle represents one number. So let's assume in this case it represents 70,000. All right. Now, the rectangle in the middle here probably represents 65,000. This is between 60 and 70,000. All right, so the height of it is 8. That's the number of numbers in the data set that have 70,000 in it, okay? The number of 70,000 that show up in the data set. That's how you read this. Now, if the y-axis was a percentage, okay, so let's say instead of 8 here, it showed, I'm just making it up, let's say it shows 25%, then it means 25% of the numbers in the data set have a value of 70,000. And that's how you read a histogram, all right? So a histogram is, now you don't see the numbers at all. This is very important. You do not see the numbers with a histogram. What you see are just the counts or percentages of the numbers in the data set that are the histogram. So a histogram represents quantitative data, but it doesn't display all the numbers. However, there's something called a stem plot. Let me just show you what a stem plot looks like. Let's go back. I think it's on the previous page. Just want to give you an example of them. Here we go. Now, stem plot is another way of visually displaying a quantitative variable, and sometimes it's called a stem and leaf plot, where a vertical line is displayed on the plot, like here, and then the numbers to the left are the tens digits, and the numbers to the right are the singles, are the ones digits. So 5 and the 4 represents 54. 5 and a 7, 57. 5 and the 8 is 58 and 59. Then we have 60, 62, 63, 63, 64, 64. Get the idea? So this also displays the shape of the numbers, the distribution. You can see whether you're skewed left, skewed right, or symmetric. But it also displays all the numbers. So the difference between a stem plot and a histogram is that stem plot shows all the numbers and the histogram does not. But they are both displaying quantitative data. And both those types of plots, the stem plot and the histogram, show 3 things. They show where the center of the distribution is, such as the mean and median. It gives you sort of an idea where it is. You still have to calculate it. Gives you an idea where the spread, how much the spread is. Now, if you take a look at these 2 stem plots here, stem plot A and stem plot B, all right, the center seems to be in both cases in the 60s, right? However, can somebody tell me which of these 2 stem plots is more spread out? Is it stem plot A or stem plot B? More spread out.
B?
B, of course. And a measure of how spread out a data set is called the standard deviation. The standard deviation. So you would expect that the standard deviation of stem plot B to be bigger than the standard deviation of stem plot A, even if their means and medians were close to each other. Also, I wanted to ask a question to you. If we have outliers, they do affect the mean and the standard deviation, because an outlier is used in the calculation of the mean and standard deviation. So for example, if you took the mean, if you look at the mean of, let's say, stem plot A, right? And let's say you added another number to the data set, maybe 1,000 or some really large number, then the only thing, the difference between the way it looks now and the way it would look if you added that number 1,000 is that there would be a really long vertical line, and then eventually you would see 1,000. Now, the median doesn't get affected by that, right? The median's still in the middle. But what does get affected is the mean, because we're averaging in that 1,000, and the mean will become bigger. So the mean is affected by outliers. The standard deviation also, because it uses all the numbers in the data set. Standard deviation is going to get larger because of outliers, or smaller. The numbers that don't get affected by outliers, this is important to know, is that the median, the one in the middle, is not affected by outliers. And the mode is not affected by the outliers. So the median and the mode, remember the mode is the most frequent number in the data set. Okay, so typically that does not get affected by outliers. But so the median does not, the mode does not, but the mean does. And the standard deviation gets affected by outliers, but the interquartile range, the middle 50% of the data, does not. Just some information for you to know in case you're being asked something like that in the test. Okay, so that's a stem plot. We have the stem plot. We have the histogram. All right. We have what else? We have the and read this part here about symmetric and unimodal and all of this stuff here. Make sure you understand all of these things that are in here. Skewed left, skewed right. Need to know that. Know about the 5-number summary. Okay. Know about box plots, how to read a box plot. Sometimes you'll be asked to compare two box plots. Remember, box plots could be vertical or they could be horizontal. Just know how to calculate the outliers. All right. So those are the things that you need to know for this test. All right. Formulas, don't need to know the formulas if you have your calculator. That's the point. So you could use Microsoft Excel. And I'm not teaching that in this course. I do have an example of how to find these things with Excel that's posted in Canvas. So if you want to take a look, you could use Excel if you want to. But just know that it's not necessary and your calculator is good enough. All right. Let's go back to, let's look at chapter 8 for a minute, see if there's any math in chapter 8. Okay, so for some reason it takes me right to the end of chapter 8 instead of to the beginning of it. Now, chapter 8 deals with, introduces you to a bell-shaped curve. All right, now, in this course, we're not going to use all the formulas that are typically taught in a regular statistics course as far as the bell-shaped curve is called. It's sometimes called a normal curve, bell-shaped. But you need to know a couple little facts about it, which this chapter is giving you information about. So that's what I want to go over with you. Sometimes you'll see, instead of a histogram, you'll see it's something that looks like this. And this is called a frequency curve, right? And this is bell-shaped. This is what a bell-shaped curve looks like, right? If you drew a vertical line down the middle of this curve, through the very top of the curve, down to the x-axis, then the left side of the curve and the right side of the curve would be mirror images of each other. Okay? So that's what it's called. There's other names that they mention here, but you're not necessarily need to know anything about it. And this is another frequency curve, which would be called skewed to the right. How do we know it's skewed to the right? Is because the tail moves to the right. All right, so this is skewed right, where we have large outliers, bigger numbers that are away from the smaller numbers. Look at the way the curve is shaped. Most of the data set is in the left and it tails to the right. So this is called skewed right. Okay. Typically, the mean is bigger than the median in a case like this. And then we also have, this is symmetric. All right, this is a normal looking histogram, so a curve is drawn like that. But we could also have skewed left, by the way, which would be the opposite of this, where most of the data would be to the right and it would tail to the left. And that's typically where the mean is less than the median. Okay. Now they talk about proportions. Remember, a proportion is just the number. You're looking at all the numbers in the data set and you're trying to count the number of values in the data set that meet a certain condition, and you divide those two numbers, and that's the proportion. Typically, a proportion runs from 0 to 1. Okay. Now, you don't need to know this table, all right? Tables are old, and you don't need them anymore. I'm going to show you basically what you need to know about what's called the normal curve, the bell-shaped curve, and just a couple facts about it. All right. All right. Now, one of the facts about the normal curve is that, maybe I should go back to the drawing of it, take a look at it again. Here's the normal curve. Because it's symmetric, okay, it means that the mean and the median are typically equal to each other. Remember, the definition of the median is 50% of the numbers are less and 50% of the numbers are greater. Well, if you draw a vertical line down through the top of this curve down to the x-axis, 50% will be to the left, 50% to the right. That's the median, and it's typically the mean, the average is equal to the median with a bell-shaped curve. All right, so we could also say that 50% of the values are less than the mean. Now, in this case here, this skewed curve, it's not true. All right, median is somewhere around here, where most of the data is, but the median, the median is somewhere in the middle, down here somewhere, but the mean is typically to the right. So in this case, the mean is typically bigger than the median because it's skewed to the right. All right. Anyway, what else can we say about the normal curve besides the fact that the mean and median are approximately equal to each other? Okay, and then again, don't worry about this table. We're not going to use it. Okay, and they're just talking about the pervasiveness of this curve. It's used in a lot of different cases, like in determining the heights and weights and IQ and all that sort of thing. Use the normal curve. All right. Now, percentiles. What does percentile mean? Percentile means the percentage of the data that's less than that number. So if they said something like you took the let's say you took the SATs, let's say you scored a 500 on the math as part of the SATs, and let's say they said that is the 60th percentile. What that means is that 60% of the people taking the SAT scored smaller than what you scored less than a 500. All right, 60th percentile, 60% of the people scored less than 500. That's what it means. There's no other meaning to it. You might see a test question like that. The only meaning is the percentage that's less than that number. That is called the percentile. And that's all it means. It means nothing else. So if you see other possible definitions, you know they're wrong. They're incorrect. Okay. Standardized scores. What does that mean? A standardized score is a way of converting a regular score to something else, to a score where it tells you how many standard deviations you are away from the mean. Now, what does that mean? So for example, let's say you had a test where the average score was 100. Suppose the standard deviation is 10. That is there's 10 that each that the average spread between the scores are about 10. Now, let's say you scored 110 on this test. Well, you scored 10 points higher than the mean, right? The mean is 100. You scored 110. Now, remember, a standard deviation is worth 10 points or 10 units. So if you scored 10 points higher, that means you scored one standard deviation higher than the mean, because the standard deviation is worth 10 points and you scored 10 points higher. On the other hand, if somebody else scored a 90, well, that person scored 10 points lower than the mean. And because a standard deviation is worth 10 points, you scored one standard deviation less than the mean. Okay? That's what we mean by standard score. Here's the formula for it. You take the score, let's say the test score that you got, 110 maybe, subtract the mean, and typically you put it in parentheses, and then you divide by the standard deviation. So if you scored 110, it would be 110 minus 100, which is 10, divided by 10, which is the standard deviation. 10 divided by 10 is equal to 1, positive. Okay? So that's what it means. So if you've got a, let's say the same situation, mean is 100, standard deviation is 10. Let's say somebody scored an 80. Can somebody tell me what the standard score would be? If they scored an 80 and the mean is 100, standard deviation is 10, how many standard deviations below the mean is 80?
Can you repeat that question again?
Yeah. What if you scored an 80 on that test? Mean is 100, standard deviation is 10. How many standard deviations below the mean did you score?
I would say 4 in total.
How many?
4.
Well, 4 standard deviations would be 4 times 10 is 40 points. Did you score 40 points below the mean?
Well,
How many points did you score below the mean if you scored an 80?
50 points.
If
Wait,
the mean is 100 and you scored an 80, how many points below the mean did you score? 20. 80 minus 100 is 20. Use your calculator. If this is hard for you to do in your head, you don't do mental math. That's why you have a calculator. Do 80 minus 100. Minus 20. That's 20 points. That the minus means you scored below the mean. Now you divide that by the standard deviation, which is 10. Minus 20 divided by 10 is minus 2. So you score 2 standard deviations below the mean. That's what you need to know for this test, is that basic idea of how to do a standard score and also how to convert a standard score to a regular score, to the original score. So if I said something like somebody scored 2.5 standard deviations below the mean, okay, 2.5, that means they scored a 75. How did I know that? Well, if a standard deviation is worth 10 points, right? If it's equal to 10, 2 standard deviations is worth 20. A half of a standard deviation is worth 5. So 2.5 standard deviations is 25. If it says minus, which is below the mean, that means you scored 100 minus 25 is 75. That's what you scored. Okay? So that's the type of arithmetic you need to know, maybe for for one of these things. And it gives you examples right here. This is why you have to read the book. Don't expect to do well in this test if you did not read the book. All right? It's essential in math to read the book. All right? Because the professors, they pick these textbooks for a reason, because they're readable. They're not real complicated. They don't have all these fancy formulas in them. They have basic formulas. This is a basic formula here. This is basic arithmetic. It's telling you to do 2 things, subtract these 2 numbers and divide by another number. That's all it's asking you to do here. You're not doing calculus here. You're not even doing very much algebra here. You're just doing arithmetic. This is arithmetic. So please just follow, and it's an open book. So make sure you read the book and you know where everything is. I'm sort of telling you what you need to know. All right, any questions about that? So what is the other fact that you need to know? This is the other fact. It is called the empirical rule. Now, the empirical rule is strictly for the normal curve. What we just did a minute ago with the standard score could be for any curve, but this is for the normal curve. And this is what the empirical rule says. And again, you don't need to memorize. It's right here on this page in chapter 8. It says that 68% of the numbers in the data set should fall within 1 standard deviation of the mean. Now, what does that mean in the case that we were just talking about, where the mean is 100 and standard deviation is 10? Well, if you take 1 standard deviation, which is worth 10 units, and subtract it from 100, that's 90. If you add 10 to 100, you get 110. So they're saying between the test scores of 90 and 110 should be about 68% of the test scores. You know, if you did this, if you administered this test for years and years and years, you would expect about 68% of the scores to be between 90 and 110. Now, 95% is between 2 standard deviations from the mean. Now, in our case, when the mean is 100, standard deviation is 10, 2 standard deviations is worth 2 times 10, which is 20. So you subtract that from 100, you get 80. You subtract 20 from 100, you get 80. And you add 20 to 100, you get 120. So between 80 and 120 should be about 95% of the test scores. And then almost all the test scores should be plus or minus 3 standard deviations. In other words, take plus or minus, in our case, plus or minus 30 from 100. Between 70 and 130 should be about 99.7%. Almost all the test scores should be within 3 standard deviations of the mean. This rule only works with the normal looking curve. Does not work with any curves that look skewed. Okay, so you need to know this also, but you don't need to memorize. It's right here. It's in chapter 8. Okay, any questions about that? I wanted to bring that to you. And this is a fancy looking bell-shaped curve. It shows you what we're talking about. In this case, we have a different mean and standard deviation. Okay, what's the mean in this case? 65. What is the standard deviation in this case? 2.5. 2.5. So you can see the mean is in the middle here, 65. Go out 1 standard deviation. You can see you go from 62.5 to 67.5. That's because the standard deviation is equal to 2.5. Mean is 65. It says it right here. The mean is 65 inches, and the standard deviation is 2.5 inches. So 68% of the heights are going to be between 62.5 and 67.5. How did we get that? We just added and subtracted 2.5. That's 1 standard deviation. What's 2 standard deviations? Well, 2.5 times 2 is 5. So we add and subtract 5. 60 to 70. It's 2 standard deviations. That's 95% of the data. All right, you get the idea? I hope you do. But this is basically the type of thing you need to know from this chapter here. All right. Now, chapter 8 doesn't have any math in it, I don't think, right? And I don't think chapter 9 has any math in it either. Let's just go to chapter 9 for a second. And yeah, and the chapter 9 are just plots, right? You had, again, just read through the plots, know the different plots, know that the difference between the quantitative plots and they call them, what do they call them? Measurement plots, whatever they call them in the book. That's for quantitative numbers. And then we have and those include, you know, the histograms and the box plots and the stem plots and some others. And then we have also the ones for the other categorical data. And what are those? Those are the pie charts, bar charts, things like that. Okay, so chapter 9 goes over that. Chapter 10, all right, relationships between measurement variables. This is where we would use our calculator. This will be the last thing I show you because we went over on our last class, chapter 12, right? I showed you how to do that. So that should be, but this is the one where you have 2 quantitative variables and we're comparing them, right? 2 quantitative variables, and we do this thing called regression. Okay, now, how do we do regression with our calculator? Okay, so suppose you have some data. Let's see if they have a data set in here, but if they don't, let's find an example. All right, so they don't really have, I just want a good example here for us to use. All right, let's see if we can find an example with actual data. But in this, I believe for the test, if I'm not mistaken, let me think about the question that I'm asking about this. Well, let me just show you how to do it with your calculator. Now, the whole idea of using a line to go through a relationship between variables is that two variables are going to have a special type of plot called a scatter plot. Okay, scatter plot. See if we could see a picture of a scatter plot. Book doesn't do a great job in showing too many of these. Wish it did a better job. Let's take a look here. See if you see a scatter plot. Here's one. All right, that's a scatter plot. Now remember, in general, you need to know the difference between upper trending, lower trending, and ones that have no trend. And correlation measures the strength and direction of a linear relationship. So in this case here, and the correlation runs from -1 to 1, where 1 means perfect positive, upper trending. -1 means perfect negative trending down. This one is trending up. We're looking at the age of wife and age of husband. Strong correlation like this indicates as the age of the wife goes up, the age of the husband goes up. And you can picture a line going through this, straight line going through this, which would represent these points, which is the scatter plot. Notice the correlation is 0.94. That is strong and positive. Strong meaning close to +1, and it's positive meaning it's trending up. Right? There's others that are trend down, and I showed all this in class. Here's an example where it does trend up, but it's not as strong. You see that it's more spread out, all the dots, but it is going up. It says the height of the wife and height of the husband. So the previous one was what? Age? I think it was age. I think we were looking at age of the wife, age of the husband, much strong, very strong, but this is also positive relationship. Typically, taller wife will marry a taller husband, typically, not always, of course. But the correlation is 0.36, so I would call this positive trend up, but not close to 1, not as strong, right? Okay, so these are called scatter plots. Now, if the correlation is close to 0, all right, like 0.05 or something like that, then the relationship is weak. Here's an example right here. Now, don't be fooled by the negative. It's just slightly negative trend here, but in essence, 0.057 is very close to 0. And you do not see any up or down movement of these points if you go across. So this is a very weak relationship between those two quantitative variables. Okay. Here's a strong negative relationship. The distance of the putt in feet and the percentage of success. This is a golf, right? You know from golf, hopefully you know a little bit about golf, that the shorter the distance to hit the ball in, the more successful you should be, right? You should expect the percentage to go up as the putting distance gets smaller. So this is an inverse relationship, and you can see it's close to -1. It's a strong negative relationship, close to -1. The thing you have to know about correlation is that it only measures the linear relationships. It does not measure nonlinear relationship. So if you see a nonlinear relationship, the correlation coefficient is not appropriate. You cannot use it. Okay. Now, the regression line, which goes through these points, these various points, is the best fitting line. Sometimes it's called the line of best fit. And by the way, you do have a quiz today, folks. So just know that there's a quiz out there for this these remaining chapters. Okay, so just reminded me of that. But anyway, regression line, line of best fit, least squares line is another name for the same line that best fits the scatter plot. typically it's y is equal to, in this book, they use a plus bx, where b is the slope and a is the y-intercept. Okay. Here's an example, 32 plus 1.8x. Now, how do we interpret that line? Okay, that line is saying that every time x increases by 1, y increases by 1.8. That's what the slope means. The 32 tells you when x is 0, what is y? That's the y-intercept. Okay, that's what that means. If we wanted to predict a y based on a value of x, we just replace the x with that number. Whatever the value of x is, we replace it, the x with it, multiply it by the slope, and add the y-intercept, and we get our predicted value of y. That's something you may be asked to do on the test. All right, so please read through this. Now, if you were going to use your calculator to do this, here's the point. I won't go through an example, but I'll show you what you need to do. In this case, we're just going to quit. If you want to quit the screen that you're in, you use second quit. And if I wanted to do a scatter plot, or not a scatter plot, if I wanted to find the regression line using the calculator, I would go to two variable statistics. So in other words, I would, when I go into data, I'm going to put my x numbers, all the x's in L1, and then I'm going to put all the y numbers in L2. The x's in L1, the y's are in L2, and then when I go to second stat, I'm going to choose two variable statistics. And then it's going to ask me where the x's are. So you choose the proper list by highlighting it and hitting enter, and do the same thing for the y's. Okay, and then scroll down and hit calc. Okay, and one of the things that it'll give you all the many of the numbers that we saw before, the mean and the standard deviation for both the x and the y, but it will also give you, besides that, and actually you're not even seeing this, are you? Nobody even mentioned that you didn't see the calculator. So let me share the calculator. All right, here we go. Let's go back. Sorry about that. And I'm just going to take a couple minutes here to go through this with you. If you wanted to find this line of best fit and the correlation, if you were being asked for the correlation, how would you do it? You're given the data set for both the x and the y. The first thing you would do is go into data and enter the x's in L1 in the first one here. Now, notice we have numbers already in here, but suppose we were given numbers for x, numbers for y. We will enter the numbers for x in L1 and then enter the numbers for y in L2. Once we've done that, then we would hit second stat and we would choose two variable statistics. We would choose that option. Then it would ask us for where is the x. So if we put it the x in L1, make sure that that's what's being highlighted. Where are the y's? Put that, in this case, let's say L2. Make sure that's highlighted. So it's asking for the x's and the y's. Then you scroll down to calc and hit enter. Now, I'm not going to do that now because I don't have anything in the y portion of the calculator at the moment. But the important point to know is that it will give you the mean and standard deviations for both the x's and the y's, but it will also give you the slope, which is A, and the y-intercept, which is B. Excuse me, I think it's the other way around. Let me hold on one second. This is, I actually have to think about this for a moment. Yes, the A is going to be the slope with the calculator, and the B is going to be the y-intercept. All right, so it's going to give you the slope and the y-intercept of that line. Okay, it will also give you what is called R, which is the correlation number. Also, it'll give you all of those numbers. So you can get the equation of the best fitting line by doing it that way with your calculator. But any questions about that? Because I wanted to show that to you before you left. Okay.
In what
Then
page
finally,
is
go ahead. I'm sorry. Go ahead.
what page is the thing you mentioned we have to calculate? What we're doing right now?
It's chapter 10.
Chapter 10?
Yeah.
Let me see.
Yeah, chapter 10. This is the scatter plot. These are two quantitative variables. You're
Mhm,
comparing them, right? To see if there's a linear relationship between them. We did this in class. We had a whole class on this. And so you have an equation, a line that goes through it, which is called the line of best fit or regression line. And I'm just showing how you, if you were given data like the X's and the Y's, how do you find the best fitting line? Now, if I give you the best fitting line, fine. You don't have to calculate anything, all right? The one thing that you might want to be asked to do is make a prediction. So how would you make a prediction? If I give you an X, you plug it in to that equation where the X is, multiply it by the slope and add the Y-intercept, and you get your Y. All right. Now, chapter 14 is the other chapter that deals with quantitative numbers. That is, of course, where we're comparing two categorical variables, correct? Two categorical variables. Again, let me just do I know we're running a minute late here, but let me just go to chapter 12. Go to chapter 12. This is what chapter we just completed. Now, please, if you haven't been attending class, you need to read through this chapter, all right? You need to go through the examples because you weren't in class, so you didn't get a chance to see this. And this was not that easy, right? I mean, most of you know that this was new and needed to be. So basically, two categorical variables. Here's an example. Actually, let me give you an example we actually did in class. We didn't do that one. Let's find another one. Let me show you. It's not that one. Yeah, aspirin and heart attacks. This is the one we did. So, what are the two categorical variables in this case? Well, we want to know, number one, is does taking aspirin prevent heart attacks? Okay. So, some people in the study took aspirin. Some people in the study took a fake aspirin called placebo, something fake. They counted the number of people later on who had either a heart attack or did not have a heart attack. And they counted based on what? Whether this is aspirin or this other thing called placebo. Well, 104 people who took aspirin had a heart attack. 189 people who took the fake pill also had a heart attack. And these are the numbers here in the second column of people who did not have a heart attack. These are the total number of people who took aspirin, 11,037, 11,034 people took the fake pill. How many people were in the study? 22,071. Now, what are the calculations again that you need to know how to do? You need to know how to calculate risk. What is risk? What is the risk of getting a heart attack if you took aspirin? It's the number of people who got a heart attack divided by the number of people who took aspirin. What's the risk of a heart attack if you took the placebo? 189 divided by 11,034. If we wanted to know the relative risk, right, we would divide those two risks. That's called the relative risk. What if we wanted to know the odds of getting a heart attack if you took aspirin? It's 104 divided by 10,933 because it's the trait that you're looking at versus the one that's not the trait. So if you're looking at heart attack, the 104 divided by the people did not have a heart attack. That's called odds. Same thing with placebo. And then you take the ratio of that, that's called the odds ratio. And also remember in class, we said those ratios can be converted into what? Increased percentages, right? How do you do it? You take the relative risk, subtract 1, multiply by 100. Okay? And once again, you didn't tell me I wasn't displaying this thing to you. You have to tell me if you're not seeing what I'm showing to you. This is what it. Were you seeing? You weren't seeing this, right? I didn't show this to you. All right. So anyway, this is the chart I was referring to. Okay, so you have to look at the calculations for risk, relative risk, odds ratio. Also, how to calculate increased risk, which is the relative risk minus 1 times 100. You can do the same calculation for odds, the odds ratio. You can convert that ratio into increased percentage. All right. Make sure you know how to do all these types of calculations in the test. All right. We went through this in class. I know we're running out of time, 5 minutes over. But anyway, make sure you know how to do these types of calculations. Any questions about anything we covered today? So you know there's a lot to review. All right. The more time you spend on this, better chance to do better. That's the whole idea. All right. Any questions? No? All right. All right. So if there's any late minute questions, you can always send me an email or something and ask it has to be a specific question, however. All right. So I'm going to stop the recording. One thing I want to say again is that the test again will be Friday. Okay, it'll stop. Make sure you're here on time. It's 11 o'clock is your starting time, right? You need to be in Zoom by 11 because we start promptly the test at 11:05. 70-minute test. This test is going to be a little bit harder than the first test. There's more number crunching, right? So make sure you don't, come in at 11:30 and you only have half. You have 30 minutes less to do this test. Make sure you're on time. All right, and their videos have to work. So if you're right now, most of you don't have your video units on, but I need to see you. So if your computer does not have a working video unit, you must use your phone to sign in. If I do not see you, and one other thing I'm going to do, I'm going to open up this. I think we can open it. Let me just check one thing here. Let's see, let me look at advanced. I just want to see if I can, I think this is a cheap Zoom that we have here. My Zoom, I have a professional Zoom and it allows me to do more than what we see here. So anyway, let me just check one other thing here. Yeah, I thought maybe I could have you change your name on here. Oh yeah. Here we go. Let me see. Share screen. No, you can't. Actually, you can't change your name on here.
All right, Professor.
All right. Anyway, that's it. Oh, I'm sorry. You have a question?
I was just going to say I have a meeting to go to.
No, go ahead. No, if you have to go. That's fine. I know I kept you over. Just make sure again your video's on. If your computer doesn't have a working video, use your phone because I cannot let you take the test without seeing you. All right, and it's just like last. All right, that's it. So I'm going to stop the recording.